Hold up your hand. Look at it. Light from your skin is hitting your eye right now. Last time I told you your body can't feel 67,000 miles an hour because you're synchronized with motion. Tonight I'm going to tell you the flip side, and it is worse. The light bouncing off your hand has never aged. Not once. Not ever. Time for a photon does not exist. Not slow, not fast. Not relative. None. A photon is born, a photon is absorbed. And from the photon's own point of view, those two events are the same events separated by exactly 0 seconds and exactly 0 distance. The universe's fastest messenger lives outside of time. Einstein whispered this in a letter 3 weeks before he died. Feynman shouted it to a UCLA auditorium in 1985. And tonight, in the next 35 minutes, you will understand why, and you will never look at starlight the same way again. Close your eyes for a second. Imagine a photon born 13.7 billion years ago in the fiery chaos of the early universe. It shoots into the void. It threads through cosmic voids. It rides gravitational waves from colliding galaxies. It slips past black holes. Entire continents on Earth drift apart. Dinosaurs rise and fall. Civilizations come and go. 13.7 billion years pass for us. And right now, a descendant of that photon lands on the primary mirror of the James Webb Space Telescope. For that photon, the journey took 0 seconds. Birth and death the same instant, same place. No waiting, no aging, nothing. And here is why the thumbnail says, destroy cosmology. I don't say that lightly. In 2022 and 2023, the James Webb Space Telescope started finding galaxies that shouldn't exist, fully formed, chemically mature, appearing just 300 million years after the Big Bang. Astronomers are calling them universe breakers. At the same time, the Hubble tension, the disagreement about how fast the universe is expanding, has become a 5 sigma mismatch that is getting worse with better measurements, not better. The photon has been trying to tell us something for 100 years. Tonight, we finally listen. Because if light is timeless, then past, present, and future already exist, and the 100-year-old story of the universe is cracking in real time. No subscribe yet. First, I owe you the proof. Michelson and Morley in Cleveland in 1887. Lorentz, who had the math but not the courage. Einstein, a third-class patent clerk. And the JWST galaxies that shouldn't be there. Here we go. In the spring of 1985, a 67-year-old man walked onto a stage at UCLA. He had just come through abdominal cancer. He had a reputation for clarity that bordered on rudeness. And for 4 hours, without notes, without equations on the board, he explained to a general audience how light and matter actually behave. His name was Richard Feynman. The lectures were called QED, Quantum Electrodynamics, and they are, to this day, the cleanest English language account we have of how the universe really talks to itself. Here is what Feynman told that room. He said, and I'm paraphrasing the spirit, not the verbatim words, a photon does not care about time. A photon does not experience distance. A photon takes every possible path across the universe simultaneously and somehow arrives at your eye. And the reason it can do that is simple. For the photon, there is no journey. There is no waiting. There is no past and no future. There is only the emission and the absorption, and those two events are one event, separated by exactly 0. That's Feynman, 1985, telling a general audience that the universe's fastest messenger lives ahead in time and outside of time. Tonight, we sit in that UCLA auditorium 41 years later. And we finish what he started. For most of human history, time was the one thing nobody argued about. Aristotle, around 350 BC, said it plainly. Time is absolute. Time is universal. A second in Athens is a second in Alexandria. Obviously, you can feel it. 2,000 years later, Isaac Newton picks up that idea and builds an entire universe on top of it. 1,687. The Principia. Newton writes, in Latin, that time flows equably without relation to anything external. Translation, there is one master clock ticking at the center of reality, and every atom in the universe keeps that beat. It's a beautiful idea. It builds bridges, it lands ships in harbors, it holds for 200 years. Because at human speeds, at human scales, it's approximately correct. And approximately is a word that can hide a multi-century lie. Then, in 1887, in Cleveland, Ohio, two men busted open by accident. Albert Michelson, a Naval Academy graduate who would later become the first American to win a Nobel Prize in Science, and Edward Morley, a chemistry professor at Western Reserve. They build the most precise measuring instrument the world has ever seen. It's called an interferometer. They float the whole thing on a pool of liquid mercury because even footsteps on the floor above would ruin the signal, and they pointed at nothing. Here's what they expect. Light was thought to travel through an invisible medium called the luminiferous ether. The Earth moves around the sun at 30 kilometers a second. So Earth should be sailing through this ether like a boat through water. Light going with the current should be faster than light going against it. Michelson and Morley's machine was sensitive enough to catch that difference easily. They ran the experiment. Nothing. They rotated the apparatus. Nothing. Different times of day, different seasons, different years. 5 years of the most careful work in the history of physics. Nothing, nothing, nothing. 8 years after Michelson and Morley's beautiful failure, a 42-year-old Dutch physicist in Leiden picks up the problem. His name is Hendrik Antoon Lorentz, and Lorentz does something astonishing. He derives, on paper, a set of equations that explain the null result perfectly. His equations say this: if you are moving fast, your measuring rod contracts in the direction of motion. Your clock ticks slower. Space is not fixed. Time is not fixed. Both of them stretch and squeeze depending on how you're moving. These are the equations that 20 years later will bear his name, the Lorentz transformations. Every physics textbook teaches them today. Lorentz wrote them down in 1895. And here's the tragedy. Hendrik Lorentz did not believe his own equations, not literally. He thought length contraction was a physical compression molecule squeezed by the ether. He thought local time was a mathematical trick to make the algebra work. He could not bring himself to say out loud that space actually contracts, that time actually dilates, that reality is underneath actually this strange. For 10 years, the greatest discovery of the 20th century sat on Hendrik Lorentz's desk. He had the math. He did not have the courage. And then an unknown patent clerk from Switzerland wrote him a letter. 1905. Bern, Switzerland. A 26-year-old man walks into the Swiss patent office every morning at 8. His title is Technical Expert, Third Class. His salary is 3,500 Swiss francs. He reviews patent applications for 48 hours a week, mostly electromechanical devices. He has no academic position, no professor backing him, no research budget. No one important returns his letters. His name is Albert Einstein. And in that 1 year, 1905, the annus mirabilis at his kitchen table in the evenings, with his wife Mailiva checking the math, he publishes 4 papers in the journal Annalender Physik. Each one is Nobel-worthy. One of them is 31 pages long. It has 0 references. It's titled On the Electrodynamics of Moving Bodies, and it kills Newton's universe. 2 postulates. The laws of physics are the same for every observer. The speed of light is the same for every observer. From those 2 lines, everything follows. Hold that. Because in the next 2 minutes, we are going to follow Einstein's one assumption that the speed of light is the same for everyone always, no matter how fast you're moving or in which direction, to the one conclusion it forces. And the conclusion is this: light is older than time. The photon that just hit your eye from your screen has never aged a single second. And if that's true, then everything you have been told about past, present, and future is about to come apart. Close your eyes. Here we go. If you just got here, welcome. Here is the whole video in one sentence. Light does not experience time, and the universe has been quietly trying to tell us this for 120 years. In the next 4 minutes, I'm going to show you exactly what a photon sees on its way from a galaxy 13 billion light years away, to the retina in the back of your eye. Spoiler, it sees nothing. It waits 0 seconds. It travels 0 distance. And when you finish this section, you will know why. Not because a textbook said so, but because you walked the budget yourself. Here is the budget. Einstein's 1905 paper gave us one rule, and the rule is this. Every single thing in the universe, you, the Earth, a neutrino, a photon, is always moving through space-time at exactly one speed. The speed of light, 300,000 kilometers per second. No exceptions. Not faster, not slower. That is the budget. And here is the twist. That budget gets split between 2 columns. Motion through space and motion through time. What you spend on one, you cannot spend on the other. A rock sitting on your desk is not still. It is spending every penny of its budget on moving through time. 0 in space, all of it in time. That is what you feel as a second passing. You feel your space-time budget flowing down the clock column. Now speed the rock up. Put it in a car, on a plane, on a rocket. Every kilometer per second the rock gains in space comes out of its clock. Its clock ticks slower, measurably. GPS satellites, correct for this? Every single day. 38 microseconds of drift per satellite per day. Not theory, engineering. Push the rock to the speed of light. What happens? Every penny moves to the space column. 0 left for time. The clock doesn't tick slowly. The clock doesn't tick at all. That rock would have to be massless to get there, and only one thing in the universe is massless enough to spend the full budget on motion. Light. Imagine a single photon. Born 13.7 billion years ago, 300,000 years after the Big Bang, inside a cooling cloud of hydrogen, the universe has just become transparent. For the first time, light can travel. Our photon shoots into the dark. For us, the clock starts. 2 billion years pass. The first stars ignite. 4 billion more, our Milky Way takes shape. 9 billion years in, a small yellow star forms on a quiet spiral arm. Call it the Sunday. 4.5 billion years after that, on the third rock around that sun, something looks up. You and the photon? It has been traveling this entire time. For us, it crossed voids bigger than 1 million galaxies. It was stretched by the expansion of space itself, redshifted from blue to red to deep infrared. It slipped past black holes. It threaded the gravitational waves of colliding neutron stars. And last Tuesday, it landed on the gold-plated mirror of the James Webb Space Telescope, sitting 1 million miles from Earth at Lagrange point 2. For the photon, none of that happened. Its clock never ticked. Its odometer never moved. Birth and arrival, the same event, the same point in space-time. 13.7 billion of our years. 0 of its. Last video, I told you your body cannot feel 67,000 miles an hour because mass forbids stillness. Tonight, the flip side, masslessness forbids time. Same rule book, opposite end, and now we have to talk about what that means for you. Look at your hand again, the one that has been holding the phone or the remote for the last 12 minutes. Light is bouncing off it right now, into your eye. How long did that light take to get there? About 1 nanosecond, 1 billionth of a second. A number so small, your biology has no idea it exists. But here is what changes tonight. For you, that light took a nanosecond. For the light itself, it took nothing. The photon leaving your skin and the photon hitting your rod cell are not 2 events separated by a short journey. They are the same event. 1 point in space-time experienced by your slow biology as 2, which means, and I want you to sit with this, you have never seen your own hand in the present. Not once. Not tonight. Not when you were 5. Not when you held your first child. Every image your eyes have ever delivered has been strictly a message from the past. Your senses are not windows. They are letters. Scale it up. The screen, you are watching a few nanoseconds. Someone across the room, 20 nanoseconds. The moon in the night sky, 1.25 seconds. You are seeing it as it was a second charter ago. The sun, 8 minutes and 20 seconds. If the sun vanished right now, you would feel no difference for 8 minutes and 20 seconds. You would still feel warm, you would still see yellow. The present has no signal. The universe runs on delayed mail, and the delay is in you, not in the photon. Now raise the stakes. The face of someone you love, across the dinner table, or on an old photo on your phone. Same photons, same rule. The light that carried that face to your eye traveled through nanoseconds for you and 0 seconds for itself. That face was, in the physical ledger of the universe, a star you happened to sit across from. I know how that sounds. Stay with me, because it is not poetry. It is the same budget we walked through at 9:30. Every photon that ever left another human skin and arrived at your retina crossed the same timeless bridge as a photon from the Andromeda Galaxy. The universe makes no distinction. Biology does. The universe does not, which is why astronomers can look at light from a galaxy 13 billion years away and say, with a straight face, that they are looking at the past, and also say, with the same straight face, that the photon itself experienced no time at all. Both are true. The first one is about us. The second one is about the messenger. And here is the quiet, unadvertised implication. If light is older than time, if every photon lives outside the ticking clock, then the light that left a face you will never see again did not vanish when that person did. It is still moving. It is still, from its own point of view, arriving somewhere in the universe on a long enough timeline that photon is still carrying that face, unaged, across a bridge that has no middle. Last video, I said your body is moving at 67,000 miles an hour and cannot feel it because you are locked to motion. Tonight, the harder truth. You are seeing the past every second of your life, and you cannot feel it because you are locked to a clock. The clock is in you. The photon is free. And that brings us to the part I have been promising since the thumbnail. How does this destroy cosmology? Because if light is outside time, then the 100-year story of a universe that began, evolved, and will end in some final future is about to get a serious visit from the James Webb Space Telescope. Here is the telescope, the James Webb Space Telescope, launched Christmas Day 2021. It did not go into Earth orbit. It was flung 1 million miles away to a gravitational parking spot called Lagrange Point 2, a place where the pull of the Earth and the pull of the sun balance so perfectly that a 6.5-meter gold mirror can sit there, cold and still, staring at the oldest light in the universe. And here is what that mirror is designed to catch: the earliest photons, the red-shifted light from galaxies that lit up a few 100 million years after the Big Bang. Exactly the photons we walked through in the last section, photons that, from their own point of view, experience 0 time on the way here. JWST is not looking at a history book. JWST is reading letters that were mailed 13 billion of our years ago and arrived unopened last Tuesday. Then, in February 2023, a team led by Dutch astronomer Ivo Labe publishes a paper in the journal Nature. 6 galaxies, confirmed redshifts between 6 and 9, which means the light left them between 500 and 700 million years after the Big Bang. That part is not the problem. Here is the problem. Those galaxies are too big, too massive, too chemically evolved, too structured. Under the standard timeline, the universe did not have enough time to make them. Astronomers started calling them universe breakers, not because of clickbait, because under the 100-year-old model, they literally should not be there. Now the second crack. It has a name, the Hubble tension, and it was already embarrassing physicists 5 years before JWST launched. Here is the setup. If you want to know how fast the universe is expanding, which tells you how old it is, how big it is, and when it will end, there are 2 independent ways to measure it. 2 completely separate tools, looking at 2 completely separate epochs. Tool 1, the cosmic microwave background, the afterglow of the Big Bang. Photons from 380,000 years after creation, photons, by the way, that experience 0 time on their way to us. The Planck satellite mapped that afterglow between 2013 and 2018 and worked backwards to the expansion rate. Answer, 67.4 kilometers per second per megaparsec. Tool 2, the late universe. Adam Rees and the SH0ES team. Using Cepheid variable stars as cosmic mile markers and Type Ia supernovae as far-side rulers, all of it recently recalibrated with JWST itself. Answer, 73.0 kilometers per second per megaparsec. Those two numbers have to agree. They do not agree. The gap is about 8%, and statistically it is 5 sigma. 5 sigma means the odds the gap is a fluke are roughly 1 in 3.5 million. For context, that is the threshold physicists used to announce the Higgs boson as a discovery, not a hint, a discovery. And here is the part nobody likes. For the last 10 years, astronomers kept hoping the gap would shrink. Better telescopes, cleaner data, calmer nerves. Instead, the gap has been getting bigger. More precise measurements have made the disagreement worse, not better. The 100-year-old cosmology is not wobbling, it is cracking. 2 independent cracks. The universe breakers, the Hubble tension. Both of them are telling us the same thing that a photon has been whispering for 100 years. The story of time is not what we were told. So what is time? If the photon is none and the universe is breaking under its own timeline. Here is the answer physicists have been quietly carrying for 118 years. Time is not a river. Time is a direction. 1908, Cologne, Germany. Hermann Minkowski, the mathematician who used to teach Einstein and once called him a lazy dog, stands up at a scientific conference and says this, quote, henceforth space by itself and time by itself are doomed to fade away into mere shadows. And only a kind of union of the two will preserve an independent reality. That sentence ended classical physics, and Minkowski was dead of appendicitis 4 months later. He never saw what he had done. Here is what he did. He took Einstein's 1905 paper and reshaped it into geometry. He said, stop thinking of space as a stage and time as the clock on the wall. Stitch them together. 4 dimensions, 1 fabric, a block. And here is the part that changes everything. In that block, every event that has ever happened and every event that will ever happen already exists as a coordinate. Your birth, this second, your last breath, all of them fixed points in the block. Right now, nothing is flowing. Nothing is arriving. The universe is not a movie being played. The universe is a film strip that has already been developed. What you call now is a slice through the block. And this is the part that still makes physicists uncomfortable. At dinner parties, the angle of your slice depends on how you are moving. Move differently, and your now catches different events. 2 observers can disagree about which event came first. Both are right. Both slices are real. 50 years after Minkowski's block, an old man in Princeton picks up a pen. It is the 21st of March, 1955. Albert Einstein is 76. He has 3 weeks left to live. He is writing to the family of Michel Besso, the friend with whom he had talked out the 1905 relativity paper. Back when they were both clerks in Bern. Besso has just died. And Einstein, who knows his own heart is failing, writes 1 sentence that nobody at the funeral would understand and that we are still arguing about in 2026. Here is the sentence, word for word. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. He wasn't being poetic. He wasn't comforting the widow with a metaphor. He was telling her in the careful technical language of a man who had spent 50 years inside the mathematics that Michel had not stopped, that the block still held him, that the coordinate point labeled Michel Besso alive was just as real as the coordinate point labeled Einstein writing this letter. 3 weeks later, on the 18th of April, 1955, Einstein died. His own coordinate closed. By his own physics, it did not vanish. And here is why this is not a story about life after death. It is a story about what light has been telling us for 100 years. If the photon experiences 0 time on its journey across the universe, then from a photon's point of view, every event it ever touches is simultaneous. Past, present, future. 1 instant, 1 point. The photon is, in a strict physical sense, a four-dimensional creature moving through a timeless block, and light is the majority citizen of this universe. We, the slow, heavy, time-bound ones, are the minority. We are the weather. The block is the climate. Einstein's last letter was not a consolation, it was a confession. Now we have to ask what it costs. Here is the question you're supposed to ask next. If every moment already exists, if the block is real, then what exactly am I doing when I choose? Am I choosing anything at all? Or am I a puppet on strings that were drawn before the Big Bang? It is a fair question. And it is older than relativity. In 1814, a French mathematician named Pierre-Simon Laplace imagined a demon, an intelligence that knew the position and velocity of every atom in the universe at 1 instant. Laplace said that demon could calculate every future, every choice, every war, every kiss, all of it written into the initial conditions. 212 years later, we still haven't shaken them off. But here is what physics actually says. And this is the part that matters. The block universe is deterministic about events. It is silent about agency. Those are two different questions, and conflating them is how smart people get stuck. An event being fixed in the block does not mean the event was forced by something outside you. It means the event includes you, your neurons, your deliberation, your gut, your values, your refusal as part of what made it so. You are not a spectator to your coordinate. You are the coordinate. The physicist Sean Carroll puts it this way: the future is determined by the present, but the present is not forced by anything you are not. You are not being overridden. You are the mechanism. The block does not steal your agency. The block is how your agency shows up in 4 dimensions. Now, here is the 2024 update you need. Even in a block universe, physics itself refuses to be fully scripted. In 2022, the Nobel Prize in Physics went to 3 men, Elaine Aspect, John Clauser, and Anton Zeilinger, for experiments that closed every remaining loophole on Bell's theorem. What they proved with lasers and entangled photons across continents is this: quantum events are not predetermined. The block holds the structure, the quantum holds the openness. Reality runs on both, which means, and this is the part you take home, you are neither a puppet nor a dreamer. You are a 4-dimensional coordinate writer operating inside a structure that is real, fixed where it is fixed, and open where it is open. The physics gives you permission to stop asking whether your choices really matter. They are what the block is made of. So here is what you do tomorrow morning. 3 things. Specific, grounded in what we just walked through. 1, look at an old photograph, someone you loved, a place you cannot return to. By the physics of this video, the light that carried that image is still, from its own point of view, arriving. The coordinate labeled them, alive, with you, did not vanish. It is part of the block. You are allowed to look at it without flinching. That is not sentiment. That is special relativity. 2, pick one unresolved regret, something you did or did not do. By the block plus quantum physics we just outlined, the coordinate where you acted differently does not exist, but the coordinate labeled today, you do the thing you wish you had done, is still open. You write it in. That is agency inside determinism. That is the deal. 3, for the next 24 hours, notice that every second you live is a coordinate you are actively signing your name to, not passing time, writing it. Your clock is not counting down. Your clock is a pen. That is the cost. That is the deal. Now let us bring it home. So line them up. Michelson and Morley, Cleveland, 1,887, 5 years of null results that nobody wanted. Lorentz, Leiden, 1,895, the math in his hand, courage he did not have. Einstein, Bern, 1,905, a third-class clerk who believed his own equations. Minkowski, Cologne, 1,908 months left to live, telling a room of physicists that space and time were shadows. Einstein again. Princeton, 1,955, 3 weeks from death, writing 1 sentence to a widow. Feynman, UCLA, 1,985, 4 hours at a blackboard, telling a general audience the photon has no clock. JWST, Lagrange, 2, 2022, a gold mirror catching letters that were mailed before there were stars. 6 witnesses, 135 years, one story. And the story was never destruction. The story was an invitation. Here is what they were all saying in different accents. The universe is not a river that you are drifting down. The universe is a 4-dimensional structure, and you are writing yourself into it, second by second, coordinate by coordinate, by the act of being the specific person you are. The photon is not a loner. The photon is the majority. You are the exception, the rare, heavy, time-bound thing that gets to feel itself choosing. And the cost of being the exception is that you mistake the clock on your wall for the shape of reality. It is not. The clock is a local instrument. The shape is the block. And once you see that, once you really see it, the thumbnail called Destroying Cosmology turns out to be the opposite. It is cosmology growing up, dropping the river, picking up the geometry, and that sets up the next question. The one I cannot answer in this video because it deserves its own. If light is outside time, what is inside it? What makes a broken cup stay broken? What makes the past feel finished and the future feel open when the block says they are both coordinates? Next time, we meet Ludwig Boltzmann in 1877 Vienna, and we find out why the universe has a direction at all and whether it can be reversed. 1 minute left. Let me close this properly. Here is the whole video, one last time. Light is older than time because mass is what makes a clock tick, and light has no mass. From the photon's point of view, the universe is a single instant. From yours, it is a life. Both are true. The block holds them together. When Feynman stood at UCLA in 1985 and told that room, the photon has no clock, he was not being strange. He was being honest. When Einstein wrote to Besso's widow 3 weeks before his own death and called past, present, and future a stubbornly persistent illusion, he was not comforting her. He was describing her husband's coordinates. And when JWST reads letters that were mailed before there were stars, it is finishing a sentence. The universe began whispering in Cleveland, 1887. You walk that sentence tonight. So here's what I want you to do with it. If any minute of this changed how you see the clock on your wall, the face in an old photograph, or the hand you're holding right now, hit subscribe. Not because the algorithm wants it, because the next video on entropy is where we find out why the universe has a direction at all. And you will want to be in the room. Hit, like if the block universe landed. Leave a comment with the one action you are taking tomorrow morning, photograph, regret, or the 24-hour pen. I read every one. Last video, I told you your body cannot feel 67,000 miles an hour because stillness is forbidden. Tonight, you cannot feel the photon's timelessness because time is required. Same rule book, both ends. Next time, we find out which direction the rule book points and whether it can be reversed. I'm glad you stayed. See you in the next one.